Okay, and let's go over problem C, minimum ties. The problem statement is that you're given an integer n. Let's say n is 8. You're given an integer n, and then this is the number of teams that are in the tournament. And in the tournament, each team plays each other team exactly once. If a team wins, it gets 3 points. If it draws, it gets 1 point. And if it ties, it gets 0 points. And so what you want to do is you want all the teams to have the same number of points, and you want to minimize the number of draws. So if I have n is 8, then basically what I can do is for every team that plays against each other, they could draw, and that will trivially satisfy the condition that every team must have the same number of points at the end. But you want to minimize the number of draws, so the question is there a better way of doing that? And so the way I approach this problem is if you just draw a table of the possible matches that can happen. So like here's teams on the like each row and each columns are teams, and then you just draw this grid. Pardon me. Okay, you just draw this grid, and then so like you only so like for example, this cell would be if team one faced team two in the tournament, and then the value at the cell is the winner. So if one wins, it'll be one. If two wins, it'll be two, and so on. The first thing to realize is that we don't actually care about everything uh, from this main diagonal downwards. Like we don't actually care about this, and like we only care about the things on the upper half. Or like one way to approach it is to only care about the things on the upper half. And so if you think about this in terms of kind of like making sure that each team wins equally, then the problem becomes simpler, right? So here we can have so like you want to kind of like approach filling this table to equalize the number of wins each team has. And so one way of doing that is that you can just fill like each row with this value, right? So at this point, each team has won once, but eight still needs to win once. And but you can just like fill 8 in anywhere here. So you can just keep on going with this pattern, right? So you go along a second diagonal, and then now 8 needs to win twice, and 7 needs to win once. And then you just keep on going. And now 8 needs to win 3 times, and 7 needs to win 2, and 6 needs to win once for every team to have an equal number of wins. Now let's see what happens if I fill out this diagonal, the next diagonal. Then 8 would need to win 4 times, but because I have filled this diagonal out, there's no more space, so I cannot fill this diagonal. So this is when I know how to stop. And at this point, you just like keep on filling things along the diagonals until you can't anymore, which is basically when this counter for 8 is it like this counter plus 1 is greater than or equal to the length of last column's free space. And then what you do is you can just fill everything out from like column by column from the end to start. So here you need 3 8s, here you need 2 7s, and here you need 1 6. And then everything you didn't fill out is just a draw. Yeah, and so basically this is how you do it. This is kind of the optimal way of doing this. And this, you kind of know this is optimal because the number of draws you get at the end is always less than, so like the number of draws is always less than n. So if like one of these, like there's no way to allocate these draws into wins because there's less than n, like there's less than n of them, and you need n, like you need to like increase wins by n in order to make sure every team has the same number of wins. Yeah, so that's basically how to do it. And so my implementation. Yeah, so I just basically implemented this. I didn't, like, there's many ways of implementing this. It's a little annoying, but yeah. So like I just started from the first column, going to the end, and then I filled in the 8 7s and 6 backwards, and then at the end I just make sure that the output format is good. Yeah, that's it.